We are studying basics of trigonometry. So we're going to learn about the relationships of acute angles and right triangles, and then we're going to determine side lengths of triangles using trig functions. So what is trig? Trigonometry is a study of relationships among the angles, and we use this symbol to denote angles, and side lengths of right triangles. A trig ratio compares the side lengths of a right triangle. A trigonometric function has a rule given by a trigonometric ratio. So just a bit of notation that we're going to use throughout this chapter is this Greek letter theta. And it looks sort of like a circle with a line through it like that. So that's sort of what theta looks like. Something like that. Something like that. That's what theta looks like. It's typically used to represent the measure of an acute angle in a right triangle. So what we're going to remember is the Pythagorean theorem. And the Pythagorean theorem stated that if A and B are side lengths of a right triangle and C is a hypotenuse, then the following relation is true. A squared plus B squared equals C squared. You should remember this from when we studied it in geometry. And just so that we have a labeling here, your C is your hypotenuse, so let's label this hypotenuse for now. And then A and B are your side lengths, so we could call this A and this B. So the trig functions, we studied the first three in geometry, but there are three additional ones. So the first three are sine, cosine, tangent. And if you recall, that was SOHCAHTOA. SOHCAHTOA. So what that says is sine, so the sine of theta would be opposite over hypotenuse. So in this triangle up here, the side opposite theta is B. And recall that the hypotenuse is always the side opposite the right angle. The cosine, according to SOHCAHTOA, is, so cosine of theta is adjacent over hypotenuse. So in our triangle here, A is your adjacent. The tangent, based on this, is opposite over adjacent. The next three are sort of, these ones are the new ones. So what I would like you to remember is this idea of what a reciprocal is. And just right off to the side, the reciprocal So the reciprocal of 1/3 is 3 over 1. The reciprocal of 2, if we think of 2 as 2 over 1, reciprocal of 2 is 1/2. Well, as it turns out, is sine, cosine, and tangent all have reciprocals, and we give these reciprocals some special names. So the first one is called the cosecant of an angle, is the reciprocal of the sine function. So the cosecant would be 1 over sine theta. It's the reciprocal of sine. And we denote this as CSC theta. So the reciprocal of sine is cosecant theta. And this would be just the reciprocal of your sine. So instead of having O over H, we would have H divided by O. So hypotenuse divided by the opposite side. Secant is the reciprocal of the sine function. So we write 1 over, the cosine function, 1 over cosine theta. So the secant is a reciprocal of the cosine function. So this is 1 over cosine theta, or we write this as secant theta. And it's just a reciprocal. So instead of having a over h, we're going to have h over h. So this will be h over a. So hypotenuse over adjacent. The last one is the cotangent. So that's a reciprocal of tangent. So 1 over tangent theta is our cotangent of theta, and that is going to be the reciprocal of the tangent. So it's going to be a over o. So adjacent over opposite. So these are the 6 trig functions, and for most problems that you're going to get there, they're going to ask you to identify each of these values. So the first one says, this example, determine the value of theta for each of the following trig functions. So it says the leg opposite theta is BC, and that equals 4. The leg adjacent to theta is AC, and that's 3. And the hypotenuse is AB, and that's 5. So let's sketch a right triangle. And let's just go ahead and put theta here, although you could have just as well put theta up there. The hypotenuse is always going to be the side opposite the right angle. So that's going to be this side. And they told you that the hypotenuse is AB. So this will be AB. And that has a length of 5. So that takes care of this third bullet point. So we've taken care of that. The leg, then let's go back to the top, and it says the leg opposite B theta is BC. So this really should, then we have this labeled backwards, and theta is really up here, because if it's got to be opposite, then B needs to be over here. So it's okay, we just have to switch where theta is, not a big deal. So the leg opposite of theta is BC. So this will be BC. This will be 4. And then the last one is going to be 3. So leg adjacent is AC. So you just want your picture to be consistent with the facts that they gave you. So this is where our theta should be. So sine theta is opposite over hypotenuse. So opposite is 4 and hypotenuse is 5. Cosine theta is adjacent over hypotenuse. So that's 3 over 5. And tangent is opposite over adjacent. So that's 4 over 3. Then for your reciprocal trig functions, cosecant is the reciprocal of sine. So we're just going to take the reciprocal of the value we got from the triangle. So instead of having 4 over 5, we're going to have 5 over 4. And then for secant, it's going to be 5 over 3. And cotangent is 3 over 4. So just so you see where these are coming from, this is hypotenuse over opposite. This is hypotenuse over adjacent. And this is adjacent over opposite. If sine B equals 5 over 8, find the exact values of the 5 remaining trig functions for B. So remember, if B is your vertex, so that's the angle we're talking about here is B. And so they give you sine, they give you the opposite over the hypotenuse. So what we need to find is we need to find this value of A first before we go on. So we're given the hypotenuse, so we're going to use the Pythagorean theorem to find A. So this will be A squared plus B squared equals C squared. I know my hypotenuse is 8, and I know my little b value is 5. So that leaves me with just plugging this in. So a squared plus 5 squared equals 8 squared. This will be a squared plus 25 equals 64. Subtract 25 from both sides. So a squared is 39. Take the square root of both sides, and you get a is the square root of 39. So this is the value of this side. This we now know is the square root of 39. So they want us to find the remaining trig function. So they give us sine. We need to come up with cosine of b. So cosine, remember, that's going to be adjacent over hypotenuse. So adjacent to b is your square root of 39. And the hypotenuse is 8. Your tangent of b is your opposite over adjacent. So here's b, opposite is 5, and adjacent is square root of 39. And then we were given the sine one. We were given sine b equals 5/8. So then the reciprocal functions. So let's start with cosecant. Remember, cosecant is the reciprocal of sine, so this is going to be 8 over 5. Secant theta is the reciprocal of, or sorry, this is b, not theta. Secant of b is the reciprocal, so this will be 8 over square root of 39, or you could say 8 root 39 over 39. Either one of those is correct. And the cotangent of b will be square root of 39 over 5. So these are your 6 trig functions. Trig functions for this triangle. And I'll tell you, just for tangent, you could have 5 over 39, or you could have 5 root 39 over 39. Either one of these is acceptable. The preferred answer is the bottom one, but if you got to the top, that would be okay. So the last idea that this section covers is inverse trig ratios. And inverse trig ratios are not the same as reciprocals. What inverse trig ratios allow you to do is find the measure of an angle given a side length. So in words, the first one says if angle A is an acute angle and the sine of A is x, then the inverse sine of x is the measure of angle A. So what this says is if sine A equals x, then sine inverse x equals the measure of angle A. And here's an example. It says if sine A equals 1/2, then sine inverse 1/2 is the measure of angle A. And so in this example, you'd get the measure of angle A is 30. The next one, inverse cosine, works the same way. If A is an acute angle and the cosine of A is x, then the inverse cosine of x is the measure of angle A. So if cosine of A equals x, then cosine inverse of x equals the measure of angle A. And then there's an example for you down there. Works the same way as the previous example, except now we have cosine instead of sine. The last one is for tangent. So if angle A is an acute angle and the tangent of A is x, then the inverse tangent of x is the measure of angle A. So that says if tangent of A is x, then tangent inverse of x is the measure of angle A. And again, they give you this example that if tangent A is the square root of 3, then tangent inverse square root of 3 is the measure of angle A. So you will want to know which of the 3 trig functions you have. Do you have a sine relation, a cosine, or a tangent? And that will allow you to take the appropriate inverse. So let's look at an example of this. So in this example, they say determine the measure of angle n. So here's angle n, and let's identify what information we're given. So the first piece I see is, here's my right angle. Directly across from that is my hypotenuse. So I'm given the hypotenuse. And here is n. Across from n, I'm given 6. So I am given opposite and hypotenuse. So there's only 2 that relate that. So you could have sine is opposite over hypotenuse, or tangent, which is opposite over adjacent. Clearly, this has to be the top one because we're not given the adjacent. So we're going to use sine of n equals 6/10. And then we could simplify this as sine n equals 3/5, but you don't have to do that step. So if we want to figure out what n is, the measure of angle n is, so we go back to that inverse trig ratio. So I'm given sine, so if I want to find the measure of angle n, it's going to be sine inverse of 3/5. And if you do that in your calculator, you would get the measure of angle n equals 36.87 degrees. And that would be the measure of angle n. And if they wanted you to round to the nearest whole degree, then this would be about 37 degrees. So that would be the measure of angle n. If you have questions on anything in 13.1, please write them down and bring them with you.